Hey, Syrena. So I was right when I got back and looked it up. It was just a stupid thing. Um, I was just using the wrong function to find the critical z. I was trying to use norm.inverse, and it's norm.s.inverse because the s means we're working in standard units. Um, uh, anyway, we're working in z's in essence. So I'm going to go ahead and work out the whole problem for you. I don't know if you need me to or not. But maybe it'll be helpful. So, a Department of Education reported in 2007, 67% of students enrolled in college or trade school within 12 months of graduating from high school. In 2013, a random sample of 320 students who graduated from high school 12 months prior was selected. From this sample, 212 students were found to be enrolled in college or trade school. All right, so then it tells us to construct a 90% confidence interval to estimate the actual proportion of students enrolled within 12 months. Okay, so in order to do this, the first thing we have to do is figure out our sample proportion. And so the data will need to figure out our sample proportion, which is p bar. We'll need our x and our n, and then that'll help us calculate p bar. So our sample proportion, so our x, first of all, is the number of students, the number of successes, if you will, the number out of the whole, out of the sample that were attending school in this case. So there were 212 students attending school out of a sample size of 320. So our proportion then is going to equal x divided by n. Oops, not the number n, but by our number. There we go, n. So there is our sample proportion. That's the first thing we need. The second thing we need is our standard error of the proportion. Standard error of the proportion. And to find that, all it is it's the square root of our sample proportion times 1 minus the sample proportion divided by n. So it's the square root of all of that. So that's our standard error of proportion. And then finally, we need the margin of error so we can calculate the confidence interval. In order to calculate that margin of error, we'll need this information, and we'll need our critical z. So our critical z, like I said, it's norm.s.inverse. And then it asks for our probability, which is our alpha divided by 2. So our alpha for this is 0.1, so our alpha divided by 2 is 0.05. And if you remember, this is going to return a negative because we're looking at the left-hand side. So if we want it as a positive, we can just take the absolute value of it. There's our critical z-score. So now, to find our margin of error, it's just going to be our standard error of the proportion times our critical z. And then our upper confidence limit is going to be our p-bar, or our proportion, our sample proportion, plus the margin of error. Our lower confidence limit is just going to be our p-bar minus the margin of error. To make our life easier, we'll round that to 3 since that's what it's asking for. So our lower is 0.619, our upper is 0.706. Then it asks us what our margin of error is. We've already figured that out, so it's 0.043. And then it asks us to think about it. It says so our confidence interval was between 0.619 and 0.706. So 61.9% to 70.6%. The claim is that it's 67%. So because the confidence interval found in part A includes the reported proportion from 2007. The sample does not provide evidence the proportion has changed since then. And that's it. So I hope that was helpful. I'm sorry that I couldn't remember that off the top of my head. And I hope you have a great day.